Is Nandini. Welcome to part 2 of AWS Developer Associate series. In this section, we'll implement auto scaling groups and load balancer by step the AWS comes. By the end, you will understand how to configure, test, and monitor and auto scale balanced infrastructure. Step 1, create launch template. Go to EC2 and launch template. Describe AMI like Amazon Linux, types of instance, pair of keys, limitations, and considerations, group for security, and role of IAM if required. We being by create a launch template which defines how instance in the auto scaling groups will be launched. Choose a base AMI like Amazon Linux 2 and select an appropriate instance type. Don't forget to configure the key pairs for SSH access, a security groups for port access, and optionally attach an IAM role for instant permission. Step 2. Create auto-scaling group. Attach the launch template. Choose the availability zones and VPC. Describes the capacity like min and max and decide. Turn on health checks. Include notifications. We create auto-scaling groups. Attach the launch template. Choose the VPC and select subnet in different available zones to ensure high availability. Then set your min and max desired instance count. The number defines how the autoscaling groups behaves under load. Enable EC2 or ELB health checks to ensure only healthy instance stay active. Step 3. Configure scaling policies. Select the type of scaling policies, target monitoring and step scaling, for example, like when less than 30 and plus 2 when greater than 70%. Scaling and a schedule. Decide on cooldown period and adding CloudWatch alarms is optional. Configure how the auto scaling groups will scale. Target tracking is the simplest option. AWS automatically adds or removes instance to keep metrics like CPU at a specific level. Step scaling allows more fine-grained controlled scheduled scaling is great for predict patterns like daily peaks. Be sure to define cooldown and warm-up time for efficient scalings. Step 4. Create application load balancer. Select application load balancer. Include listeners such as HTTP 80 or HTTPS 443. Select a minimum of 2 public subnets. Establish a security group. Turn on logging. Next, we create an application load balancer. Choose internet facing. Select at least 2 public subnets in different availability zones and add a listeners, usually HTTP or HTTPS. Assign a security groups to allow inbounded web traffic. This is the entry point of your application. Create and attach target groups. Type of target IP or instance, HTTP or HTTPS protocols, path for health check, health or either manually register instance or allow automatic scaling groups to do so automatically. Connect the target groups to automatic scaling groups and ELB. The target groups, which is where your ALB sends traffic, choose instance as a target type such as health checks paths, target path, set a health check path. This endpoint must return to health response code. When the auto-scaling groups launch instance, they will automatically registered with the target groups. Testing and validation. Reach the ELB DNS endpoints such as my LB, ELB, AmazonMe.com. Create the appearance of traffic spikes. Keep an eye in auto-scaling actions. Verify the instance lifecycle status in automatic auto-scaling groups. Checks the target health in ELB. Once everything is set up, access your auto load balancer application load balancer via its DNS names. You can simulate traffic spikes using load testing tools or scripts. Watch how the autoscaling groups scale out and in. In the console monitoring instance like cycle status and health checks reports both ASB and ELB views. Example. Target tracking and policy setup. Average CPU utilization in the measure. Goal 60, 300 seconds cooldown, 180 seconds in the estimated instance warm up time. Within a few minutes, auto scaling response to the metric. Here is the practical. Let's say that we set the target tracking policy to minimum average CPU at 60%. If traffic increases, CPU hits 75%. The application scaling groups adds automatic scaling groups adds an instance when load balancer drops and CPU goes to 25%. It scales in set warm up and cool down periods to avoid premature scaling decisions. Troubling tips. Problems. Not adding instance to the target groups. Verify health check type and launch template. Problem not triggering scaling. Check the cooldown and CloudWatch's alarms, alerts and scaling policies. ELB displays and unhealthy instance. Verify the app response code and health check path. Problems, excessive latency and optimization. Optimize app performance by using multiple available zones. Summary. EC2 configuration is defined by the launch template. Auto scaling groups oversees scaling and lifecycle management. Traffic is distributed by ALB. Automation and health are supported by CloudWatch and targeted groups. Thank you.